Hey everybody, my name's Kevin Wang. Today I'm going to talk a little bit about using your TI-84 to graph a variety of different function types. I have here my TI-84 Plus Color Edition, and let's get into it. So for the first function type we're going to go over today, we're going to go over polar graphs. And so to graph in polar on your TI-84, press mode and go down to function type. By default it's going to be on function, and then you're going to change it to polar. I go back and notice that the y equals screen is a little bit different than it was. Normally it's y1, y2, and so on. Now it's r2, r1, r2, and so on. And this is because polar graphs are in terms of r instead of y. And so notice also that if we press the variable button, normally that gives us an x, and now it gives us a theta, because polar graphs are in terms of r and theta. And when we graph it, we get a spiral, and this is a graph from theta is equal to 0 to 2 pi. And so we can change that manually to 4 pi, and we'll get more of the spiral as more of the graph. Now for the next type of graph we're going to go over graphing in parametric, which is also a pretty similar process. Go to function type, go to parametric, change to parametric. Now notice that the y equals sign is an x1t and y1t instead of r1, because parametrics are in terms of t, and when you press the variable button you get a t instead of an x or a theta. Now when we graph it, we'll get a straight line, because that x of t is equal to t and y of t is equal to t is equivalent to x is equal to y. And now we're going to go over how to graph how to graph in sequential form. So you go to mode, and you change your function type to sequential, and you go to y equals, and this is quite a bit different from the other types of functions. So we're going to go over this a little bit. Typically in BC, when you are using sequential mode, you're probably looking at partial sums of infinite sequences. And so to demonstrate that, I'm going to do a pretty simple example, a harmonic series, which is an infinite sum of the terms of the sequence 1 over n. And so we're going to take a look at how to graph that on our calculator. So if you go to second and you press stat, that'll take you to list. We're going to go to math, and we want a sum of, again, second stat list, a sequence. And then now it's going to prompt us for our data. And so expr, that is the function that that's the function, the variable in terms of n. We're going to start at 1 and we're going to end at n. This is how you tell it to iterate indefinitely. And we're going to step by 1 for integers. We're going to put a parentheses here, and u and min, this is the first value of the first value in the sequence. You can just leave it blank, and by default it'll be 1, or you can actually put in 1 yourself, and we'll get a sequential graph. And so this view of the graph isn't particularly helpful for us. Only 1/4 of the screen is really dedicated to it. So what we're going to do is we're going to window, and we're going to pick an appropriate window. We're going to go from -1 to 10, that's fine. And then y-min, we know that it's never going to be negative, so we're going to go from 0 to 4. And now we have a much better graph. We have a much better view of our graph. And knowing the appropriate window to pick requires some general knowledge of what your graph is going to look like. So when you press trace, you can actually take a look at the value of, in this case, our partial sum at some given n value, which is really helpful for if you have to evaluate the sum at some point, some n value. And if you press second graph, that'll take you to table. and that'll give you that information in a tabular form. But so do make sure to actually use all the tests for convergence and divergence on a on a sum to make sure that it actually converges or diverges, because this is just a small snapshot of how the graph is behaving. And so don't just assume that the graph is going to continue to behave as it does in your little snapshot of it. Let's say we're given a set of data, okay? And so we go to stat and edit to edit our data tables. And here I already have some data put in. And so now we want to know what this data is going to look like on a graph. Well, if we go to second and then y equals, that will take us to stat plot. And we see here that plot 1 is off. We're going to turn it on. And now we're going to have to modify our window quite a bit because these values are much larger than the standard window. So our data values went from 0 to 5, so we're going to go from -1, 6 to make sure we capture the endpoints. And then we're going to go from -500 to 11,000 on a scale of 500. Now we're going to graph the function, and it does look like this function is going to be some sort of logistic growth. And so if we want to find what that logistic equation would be, we go to stat, we go to calculate, we go down here to logistic for logistic model, and it's going to prompt us and ask us where our data is coming from. And it is coming from list 1, list 2. And you can store this generated equation as a function in your y equals. That's what we're going to do. We're going to save it as y1. We're going to calculate. And now the TI-84 is going to give you your logistic function in its standard form. C divided by 1 plus a times e to the negative bx. And it's going to list out all your a, b, and c values, which is going to be very useful if you have to do any sort of math with them. So if we go to y equals, we'll see, hey, we have our generated equation right here. And when we graph our function, we are going to find that the logistic model does match up with the data points very well, and that this is very likely, in fact, a logistic growth. We're going to go over how to do operations with vectors on the TI-84. Now, technically, the TI-84 can't actually do operations with vectors because vectors have both magnitude and direction, and the TI-84 just doesn't have that functionality. But since we're in calculus and not physics, what we can do is we can actually use lists to simulate just the magnitude of the vectors, because we're not really using direction. So I press second and then parentheses right here. That's gonna make a brace, and then the brace, between the brace, you can put values like 0 and separate them by commas. So 1 and 2, and end the brace. And let's say I want to add that to 2, 3, 4. And it's going to add together the list, and that is going to behave similar to how a vector would if you added magnitudes in the same direction. And let's say maybe I wanted to subtract them instead. It'll give me, it'll subtract them. Or if I want to multiply or divide them, it'll give me some values. So lastly, I'm going to talk a little bit about slope fields and using your TI-84 to generate them. And so slope fields as a function aren't native to your TI-84, you're going to have to either download a program off the internet, or you can make it yourself in the editor if you're so inclined to do so. And so if we go to y equals, and we write a simple function like x plus 1, we go back to the home screen, and we run the slope field function. And it's going to generate a slope field, which is going to give us a pretty good approximation of what the function slope field is going to look like. Thank you for watching my video.